Hello and welcome. My name is Brett Schuhart, and now we're going to continue the RPN calculator series with the creation of composite operations. So before we begin, let's make sure that our tests are all passing. They are. So now I'm going to jump right into it. And rather than give you a great deal of description, I'm going to let you try to figure out what's going on based on the test. Alright, so our first test. It can say add and multiply. So the composite operation is going to be add followed by multiply. I guess I need an operand stack. Assign that to a local variable. And I'm going to put some values in there. There we go. So let's see. I don't like that combination of values. Let's do this. Okay. So what I want to do is I want to do something like the following. The class doesn't exist, so I'm going to go ahead and create it. And I will create it as an iMath operator. Save that, and I want to do something like op.add has about append. I don't want to use add because add might be confused with add, the add class. That method doesn't exist, so I'll create it. And then op.append, and I said multiply. Apparently when I created this method, it didn't generalize it enough, so let's see. I will go ahead and fix that, and instead of being an add, it'll be a math operator. Alright, excellent. Finally, op.execute on the stack. And then finally, I want to verify the results. So, okay, so it's going to do add first, then multiply. So 3 plus minus 7 is minus 4. Minus 4 multiplied by 4 would be minus 16. So I think the result should be minus 16. That's what I expect to happen. So there is the test. We'll run it. It'll of course fail. Expected minus 16, but it was minus 7. Okay, so what am I going to do? I'm going to go ahead and just write this right up. Okay, so I guess this composite math operator is going to have a list of math operator list. Wrong list. List of math operator. Let's do a linked list. Alright, so I've got a linked list. Then append. So append is just simply going to go operators.add. That's pretty messed up. Let's see, we'll call this op. Apparently I won't call it op. Op. Alright, excellent. Then to execute, I guess, for and op.execute values current. Alright, there we go. I'm going to run this. Let's see what happens. Success. So I've got a composite math operator. That's sort of interesting. I can now compose any kind of operator that I want, and then when I execute it, it just executes it in the order that it was built. So let's do something a little more interesting. Let's make it so that I can register a new operator with the stack. I'm going to do this actually. In fact, I'm going to do something. I'm going to make it so that if you accidentally override an existing operator, it'll cause a problem. So let's see. First of all, I said stack. I meant the factory. So let's go to the abstract. Let's go to the factory class. And let's see. We have the registered. I'm going to add a new test first off. Adding same operator. Name fails. All right, so let's see. And I guess we used a pen add operator. Named foo, comma. Doesn't really matter what I use, so I'll say new composite math operator. All right. Now it doesn't know about this, so I'm going to go ahead and create a method. This string is actually the operator name. This isn't just a composite math operator. I want it to be any kind of math operator, and we'll call it op. Okay, excellent. Now adding that causes some stuff to fail, so let's go ahead and fix it. There we go. That was the always failing factory hand-rolled mock, and that the fact that I had to change this existing class is an example of why I might want to use a mocking library as opposed to hand rolling. Not a great reason, but it is a reason. There are ways to manage that. Okay, so now add operator named in the concrete class. Great. I'll work my way backwards. All right. Now the first time it should work. The second time it should fail. Okay, so I'm going to try to add the same thing, and this time it's going to throw an exception. All right, so first of all, I need to create that class. It is a runtime exception. All right, there we go, and I will get rid of the warning and a default serial ID. All right, so I run this, and I forgot to put in a fail. Fail should have thrown exception. I don't ever want to get to this line of code. Now I need to include that. There we go. I'll run this test. It failed. It should have thrown an exception. It did not. Now, let's make that actually do something. Okay, so I guess what I'm going to do is, I'm just going to write this. So, if dot contains key op name, and it was, what was the name of the exception? It was operator name already used. Okay. So contains key OPE. Otherwise, I will go ahead and register it. Well, actually, I don't need to do that. That's enough to make the test fail. Except that I do have to sort of add it, don't I, to make the test fail. So I will go ahead and say operators by name dot put operator name op. So now I'll run it. Did I get that working? Excellent. So notice the factory can now have things added to it. Okay. So I can build a composite by hand, and I can also add. So now I've got the beginnings of a programmable calculator. I just need a way to sort of glue it all together. I guess I'm going to go ahead and do that on the calculator for now. Then if I don't like that functionality, then I'll put it somewhere else. So let's go back to RPN calculator. There's the class I'm going to be working on. So actually, let's close everything here. New test. RPN calculator. New registration. Maybe I should call it test, but I'm going to leave it like that. Okay, we have to sort of conceptually decide how I'm going to do this. So I'm going to call this test foo until I have a better idea of what it's going to look like. I guess what I want to do is I want to be able to start the creation of an operator. I guess I'm going to put the calculator into a mode. So how's about something? I'm just going to sort of type this out and tell me what you think. You won't actually be able to tell me because you're just watching the video, but how's about this? I need an RPN calculator. Okay. And then calculator.start program. I'm going to write the test, and then after I've written the test, I'm going to turn around and code the whole thing. So start the program. Add to program. We did add to program, multiply. So I'm going to basically do the same test I just did before, but this time I'm doing it at the calculator instead of right with the composite operator. And then calculator dot save program. Then I'm going to, I guess, calculator dot set accumulator new big decimal. I think I did 4. Calculator dot enter, and then calculator dot enter again. Okay, so 4. I think I did 3, and then I did -7. Okay. Oh, save program as. I'm going to give it a name. Save program as sum, then multiply. Okay. And then finally, I guess I'm going to go calculator dot execute sum, then multiply. And assert equals new big decimal minus, let's see, 3 plus -7 minus 4, so it should be -16 as before. Calculator dot get accumulator. That's an awful long test. It's more of an acceptance test, or certainly higher level, but let's see. So I create a calculator, fine. I start a program, and then I put some values into the calculator, and then I execute the program I just wrote. All right, let's see what happens. So start the program. I'm going to go ahead and add all these methods in, and then I will write them. All right. So start program. I need a new composite math operator. Okay. I'm going to assign that to a field. Okay, composite math operator. Actually, let's see. This should be op name. So I'm going to find the operator, and then I'm going to composite. I'm going to add it. Composite.append op. So if it doesn't find it, it'll throw an exception. Otherwise, it'll add it. And then save program as. Okay, fine. This is going to my factory, and my factory is called factory. So factory dot add operator named. Okay, and the operator name I've got it as a string. Let's go. Operator name, and then the operator is composite math operator. All right, now I'm going to do something. I'm going to rename that to current program. And then once I've got this, I think that should be good for the first pass. It's not done, certainly. Let's see. I start a program. I add individual operators, and then I add the operator. Okay, let's see what happens. I'm going to go back to this test. I'm going to run it. I'm going to run it. Try that again. Worked. So I've just programmed the calculator. Didn't take very long at all. And I added the functionality first. I created the composite math operator. It's not done, but it's certainly I've got the beginnings of a useful base class. And then I added the ability to add new operators to the factory, and then I use those abilities in the calculator, and I've got this full test that actually verifies that. Now there's a lot more I could do with this, but this is the composite pattern. I will say there's a big difference between the way I use the composite pattern and the way it's listed in the Gang of 4 book. In the Gang of 4 book, if you actually look at the composite pattern, it shows things like add, remove, and so on in the base interface. I don't do that because it's a violation of the Liskov substitution principle. I would rather have someone have direct knowledge of the composite than have all the math operators have something like the word add and remove and so on it. So rather than violating the Liskov substitution principle, I don't promote all of the composite operations up to the base interface. This concludes programmability. In the next segment and the final segment for this run, I'm going to go ahead and do the exact same test that I've just done here, but I'm going to use fitness to do it. So I'm going to start from scratch, going to download fitness and everything. That's what you can expect next. Hope you enjoyed this video.